Hello, it's Jim from JetsonHacks.com. Today we're going to hook up an Arduino to control our race car from a Jetson TK1. We're also going to install software which will allow us to teleoperate the car using ROS. In our previous episode, we talked about using the Teensy microcontroller to control the car from the Jetson. After playing around with it for a bit, I found out that the only realistic way of using the Teensy was to flash from a PC or x86 host. So instead of doing that, I decided that I was going to just use the Arduino software on the Jetson and use a regular Arduino. For this particular implementation, I just used an inexpensive Nano. Let's see how we wire this board up. Okay, let's build up our little proto board. I have here an Arduino Nano, one I happen to have laying around. Let's solder it up. Now let's solder this to our proto board. I have a little Adafruit Perma-Proto half-sized breadboard here. Here's the board all wired up. Basically went and did a little bit of cleanup with my snips here and clipped off all the pins and wires. We're ready to go test it out. Okay, the first thing we're going to do here is connect the Arduino board up to the race car. The steering servo goes here. The ESC goes here. The Arduino has a mini USB connector. I'm going to take that and plug it into a USB hub that's connected to the Jetson. And the little red light comes on. In order to test out the board, we will use a teleoperation node driven by this game controller. So let's pair this game controller up with the Jetson. Turn on the game controller. Set up a new device. There it is. Continue. So we're good to go there. The next step is to install the software. We go to the Jetson Hacks account on GitHub, to the install Jetson car repository. Let's grab that address. Git clone the address. And let's switch over to that directory. We're now ready to install the software. Let's take a look at the script, see what we're going to do. This machine has ROS installed as well as the FTDI module. For this particular Arduino Nano, there is another USB to serial converter module that was installed for a CH340. So let's take a look at the script and see what it's going to do. It's going to make us up a Catkin workspace called Jetson Car. We are going to install the ROS Indigo joystick package and then install Jetson Car Teleop. After that, we'll go over and install the Arduino firmware. In order to do that, we're going to install these three packages, ROS Indigo, ROS Serial Arduino, which allows you to run a ROS node on an Arduino, another serial package to talk to the Arduino from the Jetson, and this supplemental angles package. Next, we'll generate the libraries needed by the Arduino. So let's install this. Now we're ready to configure the Arduino. Let's switch over to the Arduino sketchbook directory. Let's open up our sketch. Now let's set up the programmer. We want to use the Arduino Nano board here for this particular setup. It's on serial port /dev/tty USB 0. So let's upload this sketch. Upload complete. Let's edit bash rc. We'll source the Jetson car devil here. Okay, let's go back over to the directory here. Run jetsoncar.txt has some useful information in it. Let's run ROS core. Let's make sure our controller is on. Open up another terminal. This opens up communications with the Arduino node. So we can see that there are some topics now available to us. Chatter is one that's sent out by the Arduino, and Jetson RACECAR teleop joystick command velocity is what the Arduino is looking for. Now we're ready to start up the game controller node. So now we can see that there is also a joy topic. So let's echo that out. So now when I hit buttons and move the joysticks, you can see that there's action going on. Let's look at what is being sent to the Arduino. Cross topic list. Here's the command velocities. So linear is basically the throttle speed. When it's 0.5, it's basically in neutral. And angular is the steering angle. There's a dead man switch. When I hit the Y button and move the steering, you can see that the angular Z changes. When I press the throttle here, you can see that the linear X changes. And you can see that the Arduino is receiving the information by the fancy flashing lights. So we're looking pretty good. It's time to plug the car in and get the motors running. Okay, let's plug in the car battery and turn on the ESC. So now when I press the dead button, you can see that I can turn the wheels. When I hit the throttle button, now the right button above the trigger is set at a minimum value, so this will go as slow as the car can go forward. So when I hold down the dead man button, we have a somewhat controlled slow. The next steps are basically to put this thing together and turn it into a standalone car.